Form 7 Physics, Circular Motion. We will be discussing about the following facts in this lesson. So things like angular displacement, where objects are moving in a circle, and to deal with it we need another type of an angle measuring unit which we call radians. Sometimes degrees also will be helpful for us, and we will be learning how to convert these units. Then we will be learning about the angular velocity and the tangential velocity, the time period equation, and the acceleration equation which acts towards the center in a circular motion. And we will be understanding that the resultant force is acting for any object that would move in circular motion, which we call centripetal force. And finally, we will try to derive an equation and we will try to use them in some questions. This F equals ma, which is deriving to mv squared over r and mr omega squared. Okay, now we will see about the first thing, radians and degrees. Always remember 2 pi radians is equal to 360 degrees, which means pi radians would be equal to 180 degrees. That means 1 radian is equal to 180 over pi. So the conversion, very simple. If you want to convert radians to degrees, multiply by 180 over pi. If you want to convert degrees to radians, multiply by pi over 180. Very simple idea. Now we'll look at the first topic, angular velocity and linear speed. When this object P moves from A to B, it's not moving normally, it's moving in a circular way. It makes a distance of s meters along the curve. So we call this distance s along the curve. It makes an angle theta degrees in the center. And let's say that it takes a time of t seconds. So the normal way is we can find the speed by the distance s divided by time taken t. And there is another way where we can calculate not the linear speed but how fast the angle change, which we call angular velocity, which is omega is equal to theta, the angle that it subtends in the center, divided by time taken. Right. Then what is time period? You know about the time period. Time period means it's the time taken for one complete circle to be fulfilled. So during one time period, we know that when it completes one full circle, it subtends an angle of 2 pi radians, that is 360 degrees in the center. And it travels a circumference which is equal to 2 pi r along the arc. So these are very important facts. As it subtends an angle of 2 pi radians, angular velocity can be stated as 2 pi over capital T. And hence capital T is equal to 2 pi over omega. And linear speed can be calculated by the distance, circumference 2 pi r divided by time taken, that is time period. So link between angular speed and linear speed and radius of circle can be written by the help of these two equations, which is V equals R omega. Okay, our first example. The drum of a washing machine rotates at a rate of 1200 rotations. 1200 rotations means one rotation 2 pi radians. 1200 rotations, 1200 into 2 pi radians. And the radius is also given. What is its angular velocity in radians per second? As I told you, 2 pi into 1200 divided by time taken per minute. So time is 60 seconds. So it's 126 radians per second. What is its speed? V equal R omega. Its R is 0.5 and omega we earlier found, so it's 63 radians per second. Oh, we need to do another very important thing. It's about deriving an equation for the centripetal acceleration. We'll think like this. An object is at A, it is having a tangential velocity v, and it travels to B, still with the same tangential velocity v. But we think that it subtends an angle of delta theta, and this B is very close to A. Now, for the explanation purpose, it's far away, but we'll think that this B is very close to A. So this delta theta will be very small. If it is so, now we will move forward and see what we can do. Before moving on forward, I'll tell you about this speed v at B. I can resolute it towards delta theta. Then I would get what? V cos delta theta, which is parallel to AT. V sin delta theta, which is perpendicular to AT. If this B is very close to A, that is also towards the center. Now there is a small mathematical concept. That is, if cos theta, if delta theta is very small, cos theta will be almost equal to 1, and if delta theta is very small, sin theta is almost equal to delta theta. That happens if the time we have considered is very small. Okay, so I told you about that one. Then we'll go for the typical acceleration equation, change in velocity divided by time taken. So we'll try to find the acceleration towards AT direction. AT direction. That is final velocity v cos delta theta minus initial velocity v divided by time taken delta t. We know that cos theta is almost equal to 1, so it's v minus v over delta t. That means in the direction of AT, in this direction, there is no acceleration. That's why still v is v. Then acceleration towards the center, which is v sin theta minus 0. Why 0? Because here the velocity is in this way, it's not in this way. So initial velocity towards the center would be 0. So v sin theta minus 0 divided by delta t, it would be v delta theta over theta t, which is equal to, what is this? Delta theta over t? It is this angular speed, v omega. So we say that acceleration towards the center is equal to v omega. But we know that v is equal to r omega. So acceleration of the object is r omega squared. Or we can even say omega is equal to v over r. So we can say acceleration towards the center is equal to v squared over r. We proved. Okay, now the most important fact, required centripetal force for circular motion. Now, if you ever want to go in a circular path, sometimes you might have seen that vehicles try to skid along the path. That is because the track is not providing enough centripetal force for the vehicle to move in this motion. Okay, so according to the second law, we know that F is equal to ma. Earlier proof we learned that there must be a centripetal force, which is equal to m. Centripetal acceleration is v squared over r. So centripetal force is F equals mv squared over r, or mr omega squared. Very important equation. Now we'll think of how we could apply what we learned. There is a small plastic tube, a thread, which is attached to a rubber band, string, mass is hanging. This child is rotating this rubber band, and a small movement of the hand causes the rubber band on the end of the string to move in a circular path of radius r. This rubber band and then string may be assumed to rotate in a horizontal plane. It is assumed because practically it is impossible. Right. Example 1. Calculate the speed of rubber band. Radius is given 59 centimeter. Capital M is given. Mass of rubber band is given 80 gram. Okay, now I will go back to the question. Why capital M is given? It is providing a weight, which is the tension. That tension is acting on the rubber band towards the center. It means that is the centripetal force. That's what I have marked here. So due to M, there is a capital mg force which is equal to T. Then that T is the T value, the tension that acts towards the center in the rubber band when it rotates. So that is the centripetal force. We can apply F equals ma. So centripetal force is equal to mv squared over r. But we know that T is equal to mg, so mg is equal to mv squared over r. The question already gives us all these values except v. So calculation. V is equal to 4.3 meters per second. Speed of the rubber band is increased. Explain why m now moves to a higher position. That is a very important part of this lesson. What are the facts that we have to think? Tension is constant. Why tension is constant? Because capital N has not changed. So capital Mg is not changed. That means tension is constant, centripetal force is constant. But speed is increased in the sense the required centripetal force will increase. Can it be provided by the same tension? No. So there should be something to make the required centripetal force to go down. That is by increasing R. So if V is greater, R must also be greater. But the length of the string is constant. It can't change. It can't stretch. So only thing that can happen is M goes up, R goes towards right. The circle becomes bigger. That is the idea. Okay. So in order to calculate the speed of the rubber band, now this is also another thing where we use a particular method to find the time period. In order to calculate the speed of the rubber band, the time for one rotation must be determined. Student A is telling that number of rotations in a fixed time should be counted. Student B tells that measuring the time for a fixed number of rotations should be done. No problem. If we take a fixed time, let's say 10 seconds, what if the rotation has happened one time and a quarter? Do you know exactly quarter or whether it is exactly half or 3/4? We don't know. We can't say it with an angle. So student A, it's not an acceptable method. So then student B is saying measuring the time for a fixed number of rotations. That's what generally we do in physics experiments. We count 10 rotations. We measure the time and we divide the time by 10. We get the time period. So now you know the answer. With a fixed time, there may not be a whole number of rotations, or with a fixed time, there will always, with a fixed number, there will always be a whole number of rotations. So it would not be possible to be precise about the fraction of a partial rotation. So a fixed number is better. Right. Now the next type of questions that can come under circular motion is a bit of an angular motion, but however the circle is here. So what you see here is there is a toy aeroplane which follows a horizontal path of radius r, this one, and the string is at an angle theta to the vertical. Complete the free body force diagram. Weight is there, tension is acting along the thread. By considering the vertical and horizontal component of tension, show that the angle theta is independent of mass. So you see about the diagram first. Weight is there, tension is there, angle theta. So we can take t sine theta and t cos theta. T sine theta must be equal to weight because it's this flight is not moving up and down, it's just moving in a horizontal circle. So we can say t sine theta, that is acting always towards the center, so it is equal to mv squared over r, or mr omega squared. But we know that t cos theta is equal to mg. So instead of this t, I can substitute mg over cos theta. So when I substitute mg over cos theta, m cancels off, g sin theta over cos theta. Sin theta over cos theta becomes tan theta, g goes to the other side, it becomes v squared over rg, or r omega squared over g. That means it's independent of mass. Mass is not there in the equation. Okay, we talked about the horizontal plane, we talked about the angled plane, now we will talk about the vertical plane. The diagram below shows a sphere moving in a vertical circle. In this circle, there are three points labeled. Draw arrows on the diagram to show the direction of the centripetal force on the sphere at each positions x, y, and z. Okay, what is your choice? Will it be this side door, this side door? Yes, actually it must be always acting towards the center. That is why it moves in a circular motion. Okay. The tension in the chain varies as the sphere moves in the vertical circle. State the position x, y, z at which the tension will be a maximum, and the position x, y, z where it will be a minimum. We have to explain our answer. Okay, so first of all we will mark the centripetal force that will always be acting towards the center. Now I will mark the weight forces. This one downward, this one downward, this one downward. These black color lines, they are the tension. So when it comes to z, the point z, we say that towards the center there is tension, away from the center there is weight. So towards the center, the resultant force is equal to T minus mg. So T minus mg, or T minus w, will be equal to mv squared over r. So T is equal to w plus mv squared over r. At z, tension T is greater than weight. At x, here, tension and weight both are acting towards the center. So resultant force towards the center is tension plus weight. So tension plus weight is equal to mv squared over r, hence tension is equal to mv squared over r minus w. At x, tension force is less than the weight. At y, weight is vertically downward, tension is towards the center. They are perpendicular, so they don't affect on each other. So tension is the one that is equal to mv squared over r. So tension force is maximum at z because it is an addition, minimum at x as there is a subtraction. This one is the middle. Right. So we learned loads of things about circular motion. You can find some additional questions in page number 24 and 25 in your textbook. Thank you.